So in this video, we're looking at finding the equation of a line where you're given a xy coordinate axis, like we can see here, with the line on it, and you're given two coordinates on that line. So we'll go through three examples, the first one being the easiest kind of variation, the second one being a bit trickier, which you'll see why in a second, the third example being a little bit trickier because you've got more negatives involved, and then you can try two yourself at the end. Right, so just to go through this again, so find the equation of the line below. Just to recap, and this is really important, this is a straight line, so again, it is going to be in the form y is equal to mx plus c. That is really important. And there are two really key things we need to get here, which is m, the gradient, and c, the y-intercept. Let's begin by finding the gradient, because that's a good place to start. So the gradient, which we're going to call m, is equal to the change in the y-coordinates, or the rise over the change in the x-coordinates. But in this context, if you're given coordinates, it's better to think about it as the change in the y-coordinates. So let's begin with it. Well, first of all, right, which ones here are the x and the y coordinates? Well, the 3 and the 3 is the x coordinate, so we can go and call that the x coordinate. And let's go and call it the first x coordinate, x1, because we're given another coordinate down here, which is also x. So this 0 is also an x coordinate, and let's go and call it x2 to show us the second x coordinate. This 11 is a y coordinate. Let's go and call it the first y coordinate. This 5 is also y coordinate. Let's go and call it the second y coordinate, y2. So the gradient is a change in the y coordinates. So change meaning difference. So let's pick a y coordinate to begin with. I'm going to start with the coordinate b. You don't need to, but it's going to be easier in this case because you'll see why it will keep the numbers positive. So if I start with 11, that's my first y coordinate. So 11. Change is different, so take away my second y coordinate, which is equal to 5. Okay, so the first y coordinate, take away the second y coordinate, over, and because I started with the coordinate b, I've got to go now for the change in the x coordinates from this 3. I can't go mix and match it. I can't go 0, take away 5. I've got to do 3, and then take away that second x coordinate, which is equal to 0. So my gradient m is equal to 11 take away 5, which is 6, over 3 take away 0, which is equal to 3. So 6 divided by 3 is equal to 2. So the gradient of this line is equal to 2. So m is equal to 2. Note, and this is quite important, right? We could have, I'll do it in a different kind of show this, we could have gone the other way around with the coordinates, but it makes absolutely no difference. So we could have done, right, the gradient m being equal to change in y. I could have gone 5 take away 11, which is fine. I could have done 5 take away 11 over. If I started at a with the 5, I've got to start at a for the x coordinate, so 0, take away 3, and I will get exactly the same gradient, 2, which we'll see why now. Because 5 take away 11 is equal to negative 6 over 0 take away 3, which is equal to negative 3. And dividing two negatives, you get a positive answer. So minus 6 divided by minus 3, we get positive 2. So either way, whether you start with the b coordinate first, which we did in the first one, or you start with the a coordinate first, you will get the same answer. But what is really important is you're consistent with what you do. So if I start with b, I must do 11, take away 5, then back to b, 3, take away 0. So that's just showing you, right, either way, it is fine, as long as you are consistent with the way that you do it. So I'll get rid of this, otherwise we might get confused with what is going on there. So I've got my gradient, which is good. I'm now going to go and find the y-intercept, the c part, and if you're given a coordinate where the x coordinate is 0, the y-intercept, where it crosses the y-axis, is just going to be, right, the y-coordinate, in this case, which is 5. Because really, this is saying you're going 0 across, you're not moving in the horizontal direction, you're just going 5 up. So where we cross the y-axis, this bit here, which is the y-intercept, is equal to 5. So my c value, c, is equal to 5, and that is it. So if I'm given a coordinate with 0 as an x-coordinate, I can easily read off the y-intercept's value to be just 5. So that is important to note. Let's do that in yellow. So my c value is equal to 5. And now from here, I'm just going to put this into my equation because I want the equation of the line. So it's going to be y is equal to my m value. M is equal to 2. That's my gradient, which I calculated. X. And then I've got my plus c value, or c is equal to 5. So plus 5. Okay, and that is my answer. Y is equal to 2x plus 5. Okay, let's go on to another example. This one is a bit trickier, and it is trickier because this time you're not given a coordinate that lies on the y-axis. So previously, right, we could see, right, this point here was on the y-axis. You can just read off that coordinate there. This case, we do not have that. But we can begin in the same way as before by finding the gradient m to begin with. Okay, and m is the change in the y-coordinates. I'm going to start with the coordinate b, because in my head I'm just thinking if I do 21 take away 13, it keeps it positive on the first one, and then we'll see with that 3 take away -1 what's going to happen. Let's just go from b first though. So the change in the y-coordinates, so again, just to make sure that we know which way around we're going, the 3 here is an x-coordinate, that's going to call it the first x-coordinate, the 21 is your y1 coordinate, sorry, your first y-coordinate, and over here that -1 is your x-coordinate, let's call it x2, and that 13 is your second y-coordinate. So changing the y, I can go and do 21 take away 13, 21 take away 13, over the change in the x-coordinates. Because I started at b, I did 21 take away 13, I must then go 3 take away, so 3 take away, and then -1, so -1. Okay, I've got to have that take away -1 in there. So m is equal to 21 take away 13 is equal to 8 over, and then 3 take away -1, our hot air stuff. If we're at 3 and we're taking away cold air by 1, we're getting warmer by 1, so that means 3 plus 1, which is equal to 4. 8 divided by 4 is equal to 2. So the gradient of this line is just equal to 2. Again, I think like last time. So my m value is equal to 2. This time, right, I've got my m value. I've got to go and find the c part still. And this one's trickier this time because I can't read off from my y-axis. So now what I need to do is do a bit of substitution. So the equation of a line, we know, is y is equal to mx plus c. I know that the gradient m is equal to 2. So m is equal to 2. If I use either coordinate a or b, I can substitute in an x and a y value into my equation down here. I'm going to use the coordinate b, 321, because the numbers are both positive, it will be a little bit easier. So 3, again, is an x coordinate, and that 21 is a y coordinate. So now I've got a y coordinate, 21, I've got an m value, which is 2, I've got an x value, which is 3, and I've got one unknown, which is this plus c, which is what I'm trying to find. So I'm substituting in everything here into my equation, y equals mx plus c. So y is equal to 21, so 21 is equal to my m value, which is 2, times my x value, which is 3, plus c. And this is just an equation now that I'm trying to solve to find c. I've got 21 is equal to 2 times 3 is 6, plus c. So 6 add what is equal to 21, c must be equal to 15. 15 add 6 is 21. So my c value is equal to 15. And that there is my c value, which is good because now I've got my m value, which is 2, my c value, which is 15. So my equation of the line is just going to be y is equal to m is 2, so 2x. So y and x always just say y and x because they are your changing coordinates. And my c value in this case is plus 15. So plus 15. And that is the equation of this line here. So it crosses through the y-axis at the point 15 or 0, 15. So up there, that would be 15, that point. Okay, and the gradient is 2. And that is my answer for example 2, 2x plus 15. Example 3, similar to example 2, but just this time the line is sloping in the opposite direction, so we're going to expect to get a negative gradient, but we approach it in the same way as before. So we're trying to find the either the gradient or, let's find the gradient first, because that's the way that we do this. So gradient, again, is equal to your change in the y-coordinates. I'm going to begin by going from the a coordinate first, which is fine. You could go b first. I'm going to begin with a first and do, well, my y coordinate here is 5. So 5, take away my second y coordinate, which is negative 25, so minus 25, over, and because I started at a, I must go back to a again to do -1, my change in the x coordinates, take away 9. So my gradient, m, is equal to 5 take away minus 25 is going to be 5 plus 25, which is 30, over -1 take away 9 is -10. Okay, so I'm at -1, I'm getting 9 smaller, I get to -10. So my gradient is going to be equal to, well, 30 divided by 10 is 3, but it's -3 because I've got that one negative there. So my gradient, as expected, is negative because my line is going in the opposite direction. So m is equal to -3, which is good. So I found my m value, my gradient. I've got to go and find my c value again, and I can't just go and read off a value because it doesn't tell me what this coordinate is. So I've got to go and use some substitution into y is equal to mx plus c, knowing that my gradient m is equal to minus 3. And I can choose a coordinate to go and substitute in to my equation. And you want to really use the one, you can choose any, doesn't make a difference. You want to use the ones which have probably got smaller numbers. So a, minus 1, 5 is going to be a better one to go for. So minus 1 and 5. Because minus 1 is the x coordinate and the 5 is the y coordinate. And I've got a y value, which is 5, an m value, which is minus 3, an x value, which is minus 1. And c is the missing constant that I'm trying to find. So substitution, y is equal to 5 is equal to my m value, which is minus 3. My x value is negative 1. And I'm adding on c. So 5 is equal to minus 3 times by minus 1. Timesing two negatives, I get plus 3 plus c. So 3 at what is 5? 3 at 2. So c is equal to 2. So there we go. If I go and highlight that, my c value is equal to 2, which is my y-intercept. So this line would cross the y-axis at the point. This point here is the point 2, or the coordinate would be 0, 0, 2. Okay? And the equation of my line is going to be, I've got to put it into this form now. So y is equal to my gradient m, which is equal to minus 3. So minus 3, and then my x, and my c value is equal to plus 2. And that is my answer this time. Okay, y equals to minus 3x plus 2. And my gradient is going downwards, hence I've got that negative gradient with the minus 3. So what you can do now is, you've got two questions that you can try yourself. You can pause the video, give those a go, and you can fast forward to the end to see the answers, or you can work through with me, whatever you want really. So give those a go if you want to, and then fast forward to the end to see the answers. So the first question is saying, find the equations of the lines below. Again, they're both going to be in the form, because they are straight lines, and that's important to note. They're both straight lines, so they've got to be in the form y is equal to mx plus c. Let's begin by finding the gradients for the first one. So the gradient, let's go and write it down here. M is our gradient. Again, is the change in the y coordinates, which we can write more simply as the change in the y coordinates over the change in the x coordinates. It means the same thing as this equation up here. Change in y, change in x, we can just write like this. Change in y over change in x. Let's choose a coordinate to begin with. I'm going to start with coordinate b. My y coordinate here is minus 10. So minus 10, and change is different, so take away my other y coordinate, which is negative 16. So minus 16 over the change in the x coordinates. And because I started at b, I must begin at b again. So 0 is my x coordinate there. Take away, because change, my second x coordinate, which is negative 3. So I've got minus 10, take away minus 16. Well, this really means, okay, I'm at minus 10, and if I'm taking away cold air, I'm getting warmer by 16. So I've got minus 10 add 16, which is equal to 6. So minus 10 and 16 is equal to 6 over, and I've got 0, take away minus 3. So again, I'm starting at 0, I'm taking away cold air, I'm getting warmer. So 0 plus 3 gives me that 3. So 6 divided by 3 is equal to 2. And let's have a bit of a sanity check here. My gradient m is positive, which makes sense because I'm going kind of in the positive direction for gradient. So that does make sense. So gradient m is equal to 2. So I found my m value, which is good. I found this part, which is good. I've still got to find my c part, where it crosses through the y-axis. And this one is easier to do because it tells me exactly where it passes through the y-axis, because I'm given a coordinate where my x coordinate is 0. So 0 across and minus 10 down. So my c value is just going to be equal to this y coordinate here, negative 10. Good, so I've now got my c value, which is equal to minus 10. I've got my gradient, therefore my line is going to have the equation y is equal to my m value, or m is equal to 2. So 2x, my c value is equal to minus 10. So take away 10. And that is the answer for the first one. Good, if you got that, then that's really good. Okay, well done. Question 2, a little bit trickier this time, because this time I can't just go and get my c value, my y-intercept value very easily, because, well, there's no coordinate given to me on that point, so I've got to use a bit more substitution in the end. But let's begin by finding the gradient to begin with again. So we know that gradient m is your change in the y coordinate, so change in the y over change in the x. And let's begin with the coordinate A. It doesn't matter, as long as you're consistent, you will get the same answer. But the y coordinate here is -2, so -2. I've got to change, means take away the second y coordinate, which is -8, so take away -8 over the change in the x coordinates. I started at A, I've got to go back to A again, so -6. Take away my second x coordinate, which is -4. So -2, take away -8. Again, I'm at -2. I'm at -2. If I'm taking away cold air, I'm getting warmer by 8. So -2 plus 8 gives me 6. So 6 over. And then again, I'm at -6. If I'm taking away cold air, I'm getting warmer by 4. So that means -6 plus 4, which is equal to -2. So over -2. 6 divided by 2 is 3. I've got one negative, so my answer is going to be -3. And again, a bit of a sanity check. So is our gradient going to be negative? Well, yeah, from the graph, our line is going in the negative direction, in the downwards direction. So that is good. So our gradient is equal to -3. Good. I'm now going to go and find my C value. So I found M again. I found this. I've got to go and find C again. And this time, I've got to use a bit more substitution, because I've got to now put into the equation of a line, y is equal to mx plus c. Well, I know my gradient m is equal to -3, so m is -3. And I've got to choose a coordinate, and it is a choice that I can substitute into my equation. Both of them have got all negative numbers, so a bit trickier, but let's just go for coordinate A, because why not? So -6 and -2. Because again, right, that -6 is an x coordinate, that -2 is a y coordinate. So y is equal to -2. So I've got -2 is equal to my m value, which is -3. So -3, my x value is equal to -6. So -6, and I've got that plus c on the end, which is what I'm trying to find, that missing variable. So -2 is equal to -3 times by -6 is positive 18 plus that c value. So solving an equation, I could see this, or I could go through it and I could say, well, how do I get rid of that 18? I can take away 18 from both sides, take away 18, because then what happens there? These two cancel, which is good. And I'm left with C on its own being equal to -2, take away 18. I'm at -2, I'm getting 18 smaller, so I get to -20. And let's check it. Is 18 -20 -2? Yes, it is. Good. So my C value is equal to -20. Okay, so that is good. Therefore, the overall equation of my line is going to be y is equal to my m value, or m is equal to -3, so -3x. My c value is equal to -20, so take away 20 this time. And that is the equation of this last line. And again, let's have a bit of a sanity check. Does that really make sense? It does. My gradient is negative. I've got a negative gradient, so that's good. And my y-intercept is -20. That makes sense, right? My y-intercept is below the x-axis, so it's got to be negative, so -20, it is reasonable. Okay, if it was positive from my diagram, it would not be correct, because we can see it is in the negative y part. Okay, so that is it for this video. Hopefully that was useful, and thank you for watching. Brilliant.